right, so I want to go over page 50 first, and then we'll go over the ones that you guys did on Friday. Okay, so here we go. Shh, you guys listen up. First of all, this is an actual AP question on the free response. It was a number 1 problem. On the free response, you get 90 minutes to do 6 questions. Number 6 is the big daddy and is going to take you more times. You probably spend about 12 minutes on this problem. This problem would be worth 4 points. And so each one of these sections or parts, A, B, C, and D, would be worth 1 point. So let's grade yours and see how you did. First one says, in context of this question. So they're reminding you that they want it in context. Explain what this circled point means. This circled point is the point 3, point 4. And of course, this is the y-axis is the percent of agents. That's the context of this problem. And then these numbers are in hundreds of thousands. So, for example, that 1 is $100,000 sold last month. So this point, 3.4 means 40% of agents in the company sold up to $300,000, or you could say, probably a better way to say this would be, sold $300,000 or less. And if you do not have the or less, then it is wrong. Because 40% of agents did not sell exactly $300,000. 40% of agents sold $300,000 or less. Yes, ma'am.
On the AP test, because I wrote 40% of sales agents made $300,000 or less. Would that be wrong since we don't have like real estate company?
Oh, I don't know if the real estate company would be what would get you on that one. You said made that much. I think that would have gotten you because it's sold that much. So do try to be.
Okay, I just misunderstood it.
But
they were making like commission off of this.
Yeah, they didn't make $300,000 last month. That's how much they sold, and then they'll get commission off of that. But anyway, okay. Next, B is asking you in particular about this section here, going from 700,000 to 800,000. So that is this section up here, this little increase from 0.7 to 0.8. So that is 10% of agents. So that's what you would have to say on part B. Okay, part C. Notice that is about this section right here. They are very interested in this part that stayed flat. The part that stayed flat, since this is a cumulative frequency graph, what does that mean? Yeah, so there was no accumulation. So what I wrote, there were no sales agents that sold between $1 million and $1.1 million in that month because there's no accumulation. Okay, and then part D, I think I gave more information than needed. Now, it specifically said what is the minimum monthly sales volume in order to be in the top 20%. And that is just the number 800,000. So, but if this question had said how much sales do you need to sell to be in the 20%? If it just said how many sales or how much sales, then you would say 800,000 or more. But it did ask specifically for that minimum amount. So just saying 800,000 would get you there. All right. Questions on that? How many of you got all 4 points? Okay. Good. If you're not sure, then you might have missed it and just gotten 3.
It was just for C. I feel like they got the same, but it's no. They didn't. Like originally, I put like the same number of sale agents sold 1 million to 1.1 million.
That's maybe okay. But since it's accumulation, we want to reference if it accumulates.
Okay.
Okay, you skipped 51. Let's go to 52. Starting with this number 3. Here we go. This lowest amount was juniors at 1.6. The highest median was the sophomores at about 3.25. That's my approximation. The largest range. I did get people asking me on range if that meant interquartile range or actual range. It means actual range, high minus low. It will say interquartile range if it means interquartile range. So that was juniors at about 2.4. Now, the most symmetric was the seniors, and then I want to ask you about these sophomores right here. Those are skewed, okay, because you can see this is a lengthier amount here. So would you consider that to be skewed left or skewed right?
Skewed right.
Left.
Aha! It is skewed left. You must think of it in terms of the number line from least to greatest. So if you turn your paper so that it is situated from least to greatest, then the left side is the skew. Yeah. Okay, so that's the key. Make sure you turn your paper the correct way. All right, moving on. Number 4 is D. The key to getting that is because the key to these box plots a lot of times is knowing the percentages. This says 50%, 2 quartiles, 50% of the data is between 0 and 10. And this is the one that shows 50% of the data is between 0 and 10. Okay? All right, number 5 was C, 3 only. Because it is not categorical and you do not want to do a stem plot with very large data sets. Number 6 is D. There are 19 pieces of data and the median would be data piece number 10, which would be 80,000. Okay, number 7 I talked to a lot of you guys on Friday about. When you envision a mean, think of like a teeter-totter or, the balance beam or whatever, and wherever it balances, that balance point literally is your average. And so those did have the same average. They did have the same range from 50 to 10, which was a range of 40, depending on those exact individual values in there. And so, but the variance is different. So the variance here, this has more data on the outside edges, so that is a bigger standard deviation. And tell me what variance is.
The standard deviation before.
Yep, variance is the standard deviation squared. So if A has a bigger standard deviation, then it also has a bigger variance. Yes, ma'am. Did you have a question? Oh, okay. All right. Now, number 8 is A and 9 is D. So let's look at 8. 8 says you must have a spread of 20. It does not say that that spread goes from 260 to 280. That's an assumption. That's not necessarily true. It could go from 260 to 280, but not necessarily. It could also go from 265 to 285. It just has a spread of 20 with 270 being in there. The interesting thing is, and I want to ask you about this, it is possible that you have got this going on, that Q1 and the median could be the same value of 270, and then this goes up to 290. I want to know, how could that happen? How is it possible that Q1 and the median are the same value? Good. At least 25% of the data is 270. Imagine a number line and or all your numbers lined up, there is a ton of 270s in a row. 25% of the data is fitting right there at 270. So you just got a bunch of 270s, 270, 270, 270, 270 fitting right in there. Good. And 9 is D. Questions on that one? Okay, number 10 is D. So, couple reasons on this one. So, for one, of course, it is misleading, okay? Because, you're not you are violating the area principle because this first bar looks at least 3 to 4 times bigger than 2000. 2004 looks 3 to 4 times more than 2006, and it money-wise is not. Okay, there are a couple of reasons why it is not a histogram. First, your histogram cannot violate the area principle. So since this looks 4 times bigger than 95,000, but it is not, that violates the area principle. So it has to be drawn to scale in order to be a histogram. But in addition to that, I'm thinking that these years are really more categories than just, you know, a numerical value. I know that it's kind of a number line there too, but I think it begs the question if it is categorical, possibly, the way it was treated. Okay, moving on. Number 11 is C, because all the pieces of data must have the same value to have a standard deviation of 0. And let's look at why number 12 is B. First of all, this is half of the data. 50% of the data is located between 50 and 60. And over here, 25% of the data is located between 0 and 10. So if I'm looking at this bar, the height of that bar over there on part B is 0 to 10. That's this height right here. Okay, so there's 25% and the matching 25%. And then here, this one's the exact same size, but it's just the top part of it. So this is the top 50%. All right, and then here, this middle section is this 25% here in the middle. Okay, questions on that?
Why could it not be E? I'm sorry.
Okay, sure. Why could it not be E? Okay, because according to this, this 50% of the data is between 50 and 60, and this shows a lot of it between 40 and 60.
Okay.
And this also shows 25% of the data between 0 and 10, and I can tell you right now, that right there is not 25% of the data.
Okay.
It's more like 5.
Yeah, if that. Okay, 13 is D. Questions on that? Why it's not another one? What did you think?
We put B.
You put B. So 1 is true. Okay, because the range of a sample, you know how the sample is the subgroup to the population? So the range of a sample has to be the same size or smaller than the population. It can never be greater. So that is a true statement.
Oh, I took it the other way. I misread it. I took that the population can never be greater than the sample.
Okay? All right, number 14 is A. And so here's why. The first statement is true because, you know, we could make different bin sizes. If we had the exact same data, if we all had the same data, number 1, you could do your bins by maybe go by 5s. And I could do my bins and go by 10s. Well, if we did different bins, then we're going to put different amounts in each one of those bins, and so the histogram will look different. So yours could look different than mine. So that is true. And then the other ones are statement 2. I mean, a histogram is so similar to a stem plot. It just doesn't show the individual values. They have the same issues dealing with themselves, okay? The only additional deal that they might have is stem plots are difficult with large data sets, and histograms don't show the individual data, which is what's wrong with 3. Okay, now I had talked to y'all on Friday already. Did I not show you how, like, this goes 5, 4, and, 4, 5, and this one also goes 4, 5, and then the next one goes 1, 6, 8, and this one goes 1, 6, 8. Did I show you that? Okay, so this one goes 5, 7, and this one goes 5, 7, and 7, and 7, and so on. So, hold on a second. So what we find is that the spread on all of these on the left is the exact same spread as all of these on the right. So if their spread is the same, then range does not change, and the variance, which is standard deviation squared, does not change. So the spread doesn't change. How did B change from A? It was just every number was 10 higher. The first number here was 104. This number was 114. Next number, 105, 115. Every single number was 10 higher. So what measure is affected by addition? Addition and subtract, addition and subtract, addition and subtract affects the center only. So the mean was affected. It was raised up 10 points on distribution B. Okay, yes, question?
On 14, how is 2 not true?
Because they're similar. If anything, it would be the other way around, because histograms, you can't see the individual data values. So if anything, it might be a little.
If it, on this, I just see numbers. I don't see outliers.
So is it easier to see outliers with a histogram than a stem plot? No, because a stem plot, see this stem plot example in number 15? You could see, that's like a mini histogram. I mean, a stem plot, see, turn it on its side. A stem plot is just a little miniature histogram. It's just you can see the individual values in there. So if you can see an outlier that's way out here to the side, if you have a gap and then you got an outlier further on down here to the side, you could see it with a stem plot just as easily as you could see it with a histogram. Like this, say you have this. Is this what you're saying? It's easier to see an outlier? Okay. Think of this as a stem plot. If you had a stem plot, 145, and then, I don't know, 14 and 15, 21, 22, 23, whatever. There's your stem. Turn it on its side. 1, 4, 5, 2, 1, 2, 3, and so on. Look, and then you got this number here. That's an outlier because it's way far away from those things. All right, number 16 is C. I got questions on Friday. Do the outliers count whenever you're doing the range? Absolutely. Outliers play into the range. Number 17 is E. None of those are true. There are 13 values, and the median is this problem right here, or is that spot right there? So it's not 75, it's in the 80s. And then a 90 and above at most, the most students received an A.
Isn't that true?
5 out of 13 is not most. Most has to be, I guess, more than 50%. Did most students get an A? 5 out of 13. In order for most students to get an
I
A,
think that's misleading. 'Cause
Yeah,
it seems
I
like
agree.
out of,
I
like,
agree.
A's, B's, C's, and D's, not out
Which
of the
one got the
total.
most? Yeah.
Yeah,
Yeah, it did get.
it got the most out of each individual
Yeah.
Category, but not. It didn't get a majority overall. Yeah.
That's weird.
Okay. All right, moving on. 18 is D. Okay, because if you've got yourself some data and then you've got an outlier down here and an outlier up here, okay? I mean, taking away those outliers is going to make that standard deviation get less for sure. So taking away these outliers will definitely make standard deviation smaller. So that pretty much knocks out all answer choices except for D. And D is a possible answer if this is the mean. How could the mean stay the same? If this outlier on the bottom is equal distance away as the outlier on the top. If these are equal distance from the mean and you took them off, the mean will stay the same. So it is possible. Okay, now look at 19. This one gets lots of people. 2 and 3 are true statements, and none of these answer choices give 2 and 3 as a true statement, so therefore it's E. But let me tell you, I understand 2 is the easy one to catch. You see that it's misleading because this first bar contains 2 years, this second bar contains 3 years, and this third bar contains 4 years. So if you split this up, you know, this bar could contain 2 years and this second bar could contain 3 years worth of data. Look at these sections. Look at how big these sections are. Couldn't they technically be getting smaller from year to year to year? Mm-hmm. Yes. So they could technically be getting smaller because that is such a misleading graph. Okay, now the book says that D is the answer on 20 because they did not take literally this between 8 and 10. So, but if you take literally the between 8 and 10, then the answer is A. And finally, 21 says you suspect outliers. That means you're going to have some skew of some type. Then if you have skew, then which measure of center and spread do you prefer? Median and IQR. Ooh, okay.
What did you say about 20? I'm sorry, because I put D.
If you take literally this between, then the answer is A. But because this one here includes 8 and 20. 8 and 12.
Oh, okay.
Or something like that, yeah. All right, done. Okay, so your homework for today. Your homework is to do pages 57 through 59. That equals 1 stamp. And pages 60 to 62 equals another stamp. Okay? And then tomorrow night we'll do 63 to the end. Let me know if by the end of the class you finish both of those 2 things and I'll stamp you.